Hello friends, my name is Vivek Sharma. Today we can cover this interesting problem that's called daily temperatures. So let's quickly read through that what this problem is asking us to do. So given a list of daily temperatures and that's denoted as a T, return a list such that for each day in the input tells you how many days you would have to wait until a warmer temperature. Okay? Alright, if there is no future day for which this is possible, put 0 instead. So let's try to quickly understand what that warmer temperature means. I mean, this would be pretty easy and straightforward once we jump to the whiteboard here. So these are all the temperatures like 73, 74, 75, of course in Fahrenheit. And so these are all the numbers that denoted as the temperature, right? So the warmer means like if 74 is greater than 73 means 74 is greater than 73. What does that mean? That it is the warmer temperature, right? So let's do this. If I denote the index for each temperature here, right? 4, 5, 6, 7. So uh, what the problem is asking us that return a list for each day in the input tells you how many days you would have to wait until a warmer temperature. So if we see at the 0 index, how many days this guy has to wait? This guy has to wait only one day, right? Because the next immediate date is the warmer temperature. And the definition of warmer temperature here is that the value should be the greater than the current value, right? So 74 is the greater than the 73 and that's why it's warmer. And how many days it has to wait? Someone, if it is index 0, how many days it has to wait? Only one day. How do we know? Because it's basically the next day, right? So the next day it is 74, so that's why we can say 1 is the output for the 0 index. Now let's move forward, right? So for the 74, how many days it has to wait? Only one day, right? So because the next is 75. Now for the 75, how many days it has to wait again? So now let's count, because 71 is not greater than 75, right? So then it's 1, 2, 3, 4. So 75 has to wait 4 more days for the warmer temperature. Alright, now let's see for the 71, right? 71 also let's count here, and let's use some different color, maybe red color. So 69, because 69 is not greater than 71, so 69 and 72. So this guy 71 has to wait for 2 days, right? What about 69? So 69 has to wait only one day, because the next day it is 72, right? 72, how many days it has to wait, right? So it has to wait basically only one day, right? Because the next day is 76. Now 76, how many days it has to wait? The next day is 73 and that is the lesser than 76. So there is no option, and the problem is saying like if it is not possible then put 0, right? So if there is no future day for which this is possible, put 0 instead. So what we will do for this, we will just assign a 0 for 76 because it's not possible. I mean, it's the next day is 73. Let's assume in place of 73 we would have some, hypothetically we would have some greater value than 76, then we would put 1, right? Not 0. But in this case it would be 0 because it's 73 is lesser than 76. Alright, and for 73 of course it will be 0 because it is the last value and there is no further greater value than the 73. So when I talk about the greater value, it means the warmer. There is no warmer temperature, right? So these values indicate the temperature. Alright. So now as we understood the problem, that this is the problem is there. Now let's move forward to the solution part, that how we are going to solve this problem. Okay, so if I navigate to the next page, these are all the numbers that denote the temperature here, right? So quickly, one thing we can observe here, we are just going from left to right. So left to right means we are just checking from the very beginning of the array, and we are checking the next value whether it's a greater. Then what we are doing here, we are just saying okay, if it is exactly if it is next consecutive day, then basically it has to wait exact one day, right? Exactly one day, right? And if it is not it is not the next day, means it is not the next index, then basically what we are doing, we are just checking, okay, what the next greater value, right? Once we know that greater value, then we are counting the number of days. And how we are counting the number of days, I am not sure if you observe the pattern here, but the pattern here is to count the number of days. We are just simply reducing, I mean subtracting the indices here. And for that, what we are doing, so let's say here, if I do control Z here, so 0 1 2 3 4 5 6 7, so let's say these are all the indices, right? And so for 73, what we did here 1 minus 0. Why 1 minus 0? Because the next is 1, right? For 74, what we did in this index 2 minus 1, and that's how we are just calculating the what is the, how many days it has to wait, right? By finding that what is the greater value in the next day or any other day. So day here basically it's represent these indices, basically they are representing the days, that these are the days, right? Days means like this particular day. So this is a 0 day, this is first day, this is second day, this is third day, right? So days means here is the exact this nth day, right? Seventh day, nth day. So this is how we can understand. Now for 75, because there is 71 is lesser than 75, 69 is also lesser than, 72 is also lesser than, and 76 is greater than 75. So how we will calculate this index? It is 6 minus 2. All right. For 71, what we are going to do, let's say here 6, hold on, so not 6, basically 71, we will again do the same approach. 69 is lesser than 71, 72 is greater than 71, so basically this is 5 and minus 3, right? Because 71 is at the index 3. Now let's move forward to the fourth index, and that is 69. For 69, how we are going to calculate? It is next is 72, right? So 5 minus 4, this will be the this would be the outcome for this particular day or index, right? Now 72, right? So for 72 also it would be 6 minus 5 index, right? All right. So for for sixth index basically, let's say, so for the sixth index basically 73 is not greater than, so it would be 0, and for 73 also it would be 0. All right. So if we will just do the calculation here, so this is 1 minus 0 is 1, 2 minus 1 is 1, 6 minus 2 is 4, 5 minus 3 is 2, and 5 minus 4 is 1, and then 6 minus 5 is 1, and then this guy is 0 already, and this guy last is also 0. So basically the array that we built here is 1 1 4 2 1 1 0 0, right? So this is the array that we built here. And now let's compare from the output here, 1 1 4 2 1 1 0 0. So yeah, this is how the results should be built, right? I was just double checking uh, the whether the output is matching with the problem, given problem statement solution here from this, right? All right. So now let's move the next step as well. So this is how we are just doing the subtraction of the indices. Now what is the mechanism, like how we can do this subtraction of the indices, right? So we already know that these are all the indices. I'm just writing it down again here, 5 6 7. So generally in these kind of the problems, or where this kind of pattern is there, that we are just moving forward and then we have to again come back to see that okay, what is the value, and then we have to do the subtraction, right? In these kind of problems, like one data structure is pretty much useful and helpful basically for us to do this calculation, and that data structure is called stack. Why stack is here? Because we will just keep pushing the whatever the value we want, we can just put into the index, and once we will move forward, and once our business logic meets, once our condition or logic, business logic I meant here is whenever we work in some project or something, then that's why I need the business logic. But in this particular problem, we can say the condition, right? So condition is whenever the warmer temperature we see the warmer temperature, then in that case what we will do, we will simply pop from the stack. Okay, this is the last visited value and this is the current value. We can do the subtraction and this would be our output, right? And here we are doing a subtraction for the days, means for the indices, right, for the index. So let's move forward and see how the stack is useful here. So let's traverse through the first here 0. So why we will put the index in the stack, this should be clear from the previous page, because we are doing a subtraction in the indices, but we are not doing the subtraction for the value here is the temperature. And temperature is useful to check the warmer temperature, whether it's the warmer temperature or not, right? But actual calculation we are doing on the days, like how many days it has to wait, means how many indices it has to jump, right? So index here is denoted by the days, right? So that's why we will put the indices, not the value. Just wanted to make this clear because this is the important point here, and most of the time we can confuse easily. Okay, why we are not putting the value? Because the problem is asking us to calculate the number of days, and number of days we are calculating with this calculation with the subtraction of the indices, right? So that's why we will be putting the indices, not the actual values. All right, so let's go ahead and move forward, right? So let's say we just go to the very first index, and that is a 0. We will push 0 into the index. Okay, now we will move forward. At the first index we will check, okay, 74 is greater than 73, right? So the current index now it is 1, and current index value it is greater than the this value 0. So we will pop 0, and then we will just whatever we will pop 0 at the 0th index, what we will do, we will just put 1, right? Because 74 minus 73, so not 74 minus 73 but 1 minus 0, right? So 1 minus 0 is basically this first index minus 0 index. All right, move forward. So now we will push the 1 as well to the stack. Now we will just move forward to the second, means index number 2 and actual third location but index 2. All right, so we will check, okay, the current value is 75 but index first is having 74, right? So what we will do, at the first index we will put 1. And how it is 1? Because 2 minus 1 is 1, right? And it might be confusing, don't do the subtraction 74 minus 73 and 75 minus 74. We are just here, just pay the attention of the days, like how many days we have to wait. And when the days is basically days represented by the indices here, index, not the actual values. These are the temperatures, right? So these are the temperature and these are the days, right? So these are the days and these are the temperature, right? Temperature. All right, so uh, yeah, this is not too much readable, but just try to understand from the hints, right? So days and temperature. All right, so now let's move forward quickly here, and we are now at the index 2. So index 2 we will just push to the stack here. And now for the 2 basically 2 we already covered, right? So 2 we now push to the index, sorry, to the stack. Now we are on the index third, right? So index third, what happened, that 71 is not greater than 75, right? In fact it is vice versa. So previous temperature is greater than the current temperature here. Okay, then in that case what we can do, we can simply push to the stack. We will move forward and we will find the candidate of whatever the greater than 75, that's what we will find. But anyways, right? So now let's put the 69 here, sorry, third index, and that is 71. Now our current index is fourth, and that is 69. 69 is also again not greater than 71. Then what we will do, we will just move forward, and that is the index number 5 and 4 also. We will in after we will check, okay, 69 is not greater than, after that we can push 4 also to the stack. All right, now we are at the index 5 and that is 72, and we will check our stack, right? So we will check our stack, that the previous value, right? And that's why we are maintaining this data structure called stack, so that we can just go back into the time and we can check, okay, stack, dear stack, give me the previous day data, right? So it will, this fourth index will give me the previous day of the data, and that is 69, that is greater than. So what we will do here, 0 1 2 3 4 5 6 7, let's say this is my output result, output array. So at the fourth index because 4 I am just popping from the index. What I will do, it's 5 minus 4, so it will also 1. I will put 1 here at the fourth index in the output area. All right. Now, uh, so this now fifth is done, right? And now I will check again the fifth from the 3 as well, right? So 3 at the third index. What is third index? So third index I will pop from the stack here, and I will check 71. So 71 is also less than current index, and current index is 5 at this point, right? So 71 is also less than 72, means 72 is also greater than 71, means 72 is the warmer temperature in comparison of 71. Then what I'm going to do, at the third index that I popped from the stack, at the third index I will put the subtraction. Subtraction means 5 minus 3, right? So at the third index I will put 5 minus 3, and that is 2. All right. So current index is 5. My stack is still not empty, right? Stack is still having some value, and that is the second, right? So if I check, means second index, and that is 75, and my current index is 75. So 72 is not greater than 75. So I will not pop this value, right? I just need to pop whenever I find the warmer temperature, means whenever I find the greater value, right? My current index should have the greater value in comparison of my stack data, right? Previous data. If it is not the condition, then I'm not going to pop from the stack. Okay. All right. So so current index that I also will so let me the continuation. So now the stack is having 2, and then I will post the 5 here, right? Now let's move forward to the next index, and that is 6, right? So 6, right? So 6, the current index, and the current index, let's check at the 70, at the 6th index I have the data at 76, and the previous index, that is 5, that is having 72. So what I will do, I will pop 5 here, and at the index 5 I will put here 6 minus 5, and that is 1. All right. So that's done, right? Now current index is 6. Now again I need to check, okay, at the index 2 what is the value? So at index 2 the value is 75, and current index is having 76. Then what I need to do, I need to do basically 6 minus 2 is 4 at the current index, sorry, at the index present in stack. So I will pop 2, and or the index 2 I will do 4. And why 4? Because 6 minus 2 is 4. Current index is 6 right now. Okay, now I will push 6 as well because the stack is empty now, right? So this value is also popped up here, right? So I will cross this as value here in this stack as well, just to avoid any confusion. And after 6, basically what I need to do, I will just move forward to the next index, and that is say 7. I will check, okay, my index at stacks in the stack is 6, and is it 73 is greater than or 76 or not? No. So 73 is not greater than, 73 is basically less than 76, right? So in that case, basically what is going to happen, I'm not going to pop this, and then of course I will push 7 as well, right? So by default these arrays will have 0, right? Because by default if I am assigning some index, that will have 0. So I'm not going to pop 7 and 6, they will still be in the stack, but this till the time I will be building this result output. So I hope this approach should be clear, uh, and I would again revise before ending this video, but let's quickly do the implementation, whatever we are thinking and we are assuming. So here let's quickly take the stack here, and stack will hold the integer value here, stack, new stack. Okay, and let's take result array as well, integer res, and then this is basically new int, and this would be t dot length. And now we need to traverse through this array, given array, integer I equals to 0, I is less than t dot length, and then I plus plus. Now stack dot push, we need to definitely push the index, right? and even before pushing the index, what we are just checking, we are just checking in the stack, right, and the current index, right. So now let's check this as well. And why we are checking while here? Because you observe, like, we are just checking till both two conditions are meeting or not. One, if stack is not empty, right, so stack is empty or something. So let me use the different page here. So one condition is basically whether stack dot is empty, right, so this should not be empty. That is one condition. And second is basically the current value, right. So current value means at the current index, whatever the current value, that should be the greater than the value at stack, right. At stack means whatever the index is there in the stack, that should be greater than this. And if it is greater than, then we are just putting the value basically in our res, and that would be the stack, whatever the uh, so whenever see the value at index at stack, right, so index at stack, right, because we are pushing the index itself in the to the stack, but we are not pushing the value, right. So let me do it little bit more clear. At index at stack, okay. So if this is the case, then what we are doing, res, and whatever index at our at index at stack is there, that will be here, and then that would be the sub, and we will do the subtraction, right. So what we will do, current val, so current vals means here the this would equals to current index, right, current index minus index at stack, right. So minus here index at stack, and that would be index at stack here as well, right, index at index here, index at stack here as well, and that here as well. So that will hold basically the subtraction, and that's what we were just trying to do here, okay. So let's put these two conditions here, and I apologize if I hodgepodge and if I put more confusion, but what I would focus more on to digest the concept, right, what is this concept is there and how we are solving this problem, and then probably just go back and just see the video again if there is any confusion. So let's do this, right. So current value is here is ti, and if it is greater than basically t stack dot peak, so whatever the previous value in the stack, and if it is greater than, then what we are going to do, res stack dot pop, because these two conditions are meeting, right. So these two conditions are true, then we are going to store, we are going to build our output array. So let's go ahead and do that, right. So I minus stack dot pop, so I need to do peak here because I want to pop at one time only, right. So I will do peak here, and then I will pop here, right, and that's it. So code is straightforward once we understand the what is the problem, I mean what is the problem and what is the approach that we are going to take, right. So this is new, and this is exactly what we are doing here, right. So that's what we were just discussing, that this is how we can do. Let's do this, let's quickly see. And the time complexity still would be linear, so if and there are n elements, then we have to traverse through each and every element, and for each and every element we are just checking our stack as well. So this would still be order of n. So in the worst case, we have to basically, we are just checking each and every temperature at each and every index, right. So it would be n. Space complexity, I would say this would also be in the worst case order of n. Let's assume like they are at the increasing, all the temperatures are in increasing order, then we have to put all these temperatures, basically all the indexes in the stack. But at given point of the time, basically we are just our index will be holding only the increasing combinations, but not for all, right? So but in the worst case it would be still be linear. So I am just whenever we discuss the complexities, it should be the approx complexity, right, not the exact pinpoint. So I would still be saying that it will still be the linear order of n complexity for the space complexity as well. Let's quickly check for the typo and other typing mistakes that I did, if there is any, because I mostly focus on explaining the thing. So I think this is working. This particular input is working. What we can do, we can just go ahead and submit, and we can check whether it's our assumptions and all the things are still valid. So it looks like this solution is working, whatever we expected. Now, before ending this video, basically there are quick summaries that I wanted to repeat, right? And the quick summary is basically, first of all, the we need to see the pattern, right? And the pattern here is basically index. Whenever we are having this given integer array, here the index, basically we have to assume that they are the day, right? So one index represent the one day. This is what we need to understand first. Now here the value represent the temperature, right? So array value represent the temperature, right? So and so temperature means if it is a greater value, then it is a great warmer temperature, right? So these are the basic points that we need to understand first. Now third is the power of stack, right? So I will simply say a stack. Its power means I mean the benefit of a stack, not the exact mathematical power, but the what is the benefit of a stack, right? So a stack is basically because we can go back to the time, and we can go back to the time means we can go to the previous day, and we can just compare from the current day that what is the uh, greater value, or what is a warmer temperature or something, right? So that's why we are just using a stack. So if we can just create the placeholders of these two three observations or facts, then we can build basically the implementation part, and that should not be that much big deal, right? So implementation part is basically this one, right? So like this, we can go through each and every value, and we can check what is the greater value. If current index is having greater value than the previous index at the stack, then basically we are doing the subtraction, current value minus uh, this current index minus index at stack, and result output is basically is also having the particular index means index at the stack, and that would hold the, that's how we are building the result output. So that's it. I'm not sure what else I can add here. These are the very key points. Basically index represent the day, value represent the temperature, and the stack we need to for the implementation, because we are going back to the time means we are just going back the previous day, and we are just checking whether we are hitting the warmer temperature at the current day or not. If we are hitting, then we are just doing the subtraction of the current index to the previous index, and that's how we are just calculating the how many days that person has to wait. So if these observations are clear, I think this couple of lines code should be straightforward. And important point here is also we are using while. Why we are using while? Because let's assume like whenever we are just going through, right? So let's assume like 75, right? So for the 75 we did not 71 is not greater than 75, right? So third index is having 71, right? So means this guys does not have greater value than the 75. Then we are just going to the next value. 69 is also, so also not the 71. So 75, basically we are just holding this particular index, we are holding to the stack, right? That's why we just need to do the while, right? And then 72 we hit, now it is greater than 69. So at the fifth index, let's say this is the current index, and we are just checking, okay, 69, if it is greater than the previous index, then we are just updating the value at the index 4 in our output result. But at the same time we need to check at the third index, that is 71, so that is also lesser than 72, right? And that's why we are using while here. right? Just to make sure that all the days basically we are just calculating correctly or not. And that's why that is the use of while. So it's not only for 69, but it's also for 671 and also for 75 going forward, right? So 75 is not greater than, I mean 72 is not greater than 75, so that's how we will still hold. But for at least 69 and 71, this while loop will be useful, and that's how we will just calculate for the index 4, for the index 3, by subtraction of 5 minus 4 and 5 minus 3, right? And that's how we will populate these particular index in the result output array. All right, I will not stretch it further, this video, because it's already lengthy. So hope you enjoyed that. Thanks a lot. Have a good one. Bye.